I'm CK. Tonight I think we'll have an interesting little disassembly project. This is a COVID PCR test for home. We're all familiar, I think we're all familiar, with the antigen test, the nasal swab going into the little test card with some drops of supporting fluid. This is a little bit more complex, and it comes with an actual electronic part with it. This is a used kit, came up negative just to be clear. So we'll take a look at it, see what's inside. Hope you enjoy the video. So here's the device. This is a completed test, so we're not going to be actually running a PCR test live. PCR tests are described to be more accurate than antigen tests, so this is a little more complicated of a setup. Let me go through this. I'm going to take the batteries that are in here out because they're dead, because the test is about, it was run about 3 days ago. This will go in the trash, it'll go clank. So to get set up, you do the standard stuff. There's this test vial, you swab your nose, you put it in here, swirl it around maybe 30 times, set the vial in this base and press it in. The light flashes telling you it's working, and then it'll give you an LED for done and a positive or negative result. I'm going to put some fresh batteries in here just to see if it'll still show some activity. And it does. So the test still records, must have some static RAM or non-volatile RAM. So the test is done and it came back negative. Oh, by the way, this is from a company called Lucira, L-U-C-I-R-A. I don't know how much it costs. I know it costs quite a bit more than the antigen simple nose swab test. I'm not going to pull the vial out, and I'm obviously not going to open it. But let's see what we can do. I'm going to take these batteries back out because we don't need them. Just wanted you to show or see that part of it. Interesting that it takes AA's that you have to install. It came with 2 AA's, but that's interesting just because I would almost expect they would put a little lithium battery in here, but I guess not. There's a little tab here as we start to take this apart, and that didn't do much of anything. Let me get a different screwdriver for that. One of these screwdrivers may fit better. That fits almost perfectly, and it starts to come apart. As you can see, there's no screws or anything here, just a battery box with contacts for the battery. In here you might see there are 1, 2, 3, 4, 5, 6, 7, 8 pads in there, as if maybe you can mount this on something for testing it or something like that. So we'll take this all apart. There's the contacts for the battery connection, power connection, that land on these 2 pads. Looks like one big circuit board, even though it's interesting, there's a big gap here. I don't know why. And then these are little nerds that probably keep the board in. I'll see if I can get them off without destroying them. Not guaranteeing I can. I think I'm just going to go ahead and destroy them. Take my flush cutters out and pull them out, take the tops off them. Okay, that's ready to come out, I believe. Let's see, I'm going to zoom in a little bit on this so you may be able to see this. There's some text on the board. It's got a LR, Underwriter Labs, SS1, paren 2. Down here it's got 32 something, I think that's probably a serial number. And then a little triangle, 94V-0. E is in Echo, 229342. Don't know what any of that means. Back up. See how oh, that comes out very easily. Oh, look at that. That's pretty neat. Huh. Okay, I'm going to be guessing on a lot of this stuff, of course, but this is a really neat little thing in here. Let's look at the board first, and I'll zoom back in. Let me get my solder pad here. I'm mainly using the solder pad so I know if I'm on the solder pad, I'm in the frame. So we've got some more text. Part number PCB A004-2, Rev A, and here's the serial number. I won't read that off because that's boring. So we've got one microcontroller. Try and just get the GD32E23 is the first line of text. Cat6 AS9L AQ, I'm not sure. JJ2106, and it says SIGA device here, and then there is a manufacturer. I think that says ARM, but I'm not certain. And we've got some surface mount components. There are the LED for done is here. The LED for ready is here. The LED for positive is here, and the LED for negative is here. Then here, this is what's really kind of neat. There's a whole bunch of exposed circuit material here, and there's a little bit of, I'm going to touch this, yeah, there's a little bit of sealant or conductive paste or something, I'm not sure. This is an LED, and then there's LEDs here, 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 and here. This, I don't know what kind of LED that is. That looks almost, it's got 1, 2, 3 leads connected, and there's a resistor there. These are more standard LEDs. Let me get my meter up, and we'll see if we can get these things to light up, maybe burn my eyes out. Light these up. It's yellow there. Yellow there. Can you see that? I can't tell if you can see that. Yeah, you can. I'm going to turn this light off anyway. So these are all yellow LEDs. Same as these guys. I don't know which. side is positive and which side is negative. Okay, those are the green LEDs. Now this big one in the center is the most interesting one. I'm going to see if I can get this to light up, but I don't know what it actually does really. That didn't work. No, I can't get that to light up. Oh, look at that. If I put, you can't see it. I'm gonna, hold on a second, I'm gonna go actually feed this 3 volts, so hold on a minute. Okay, so I'm gonna give it 3 volts at with half an amp available. Okay, so I'm burning that out. I'm going to go down to 2 volts. And that's still a little much. I'm going to go down to 1 volt. And 1 volt is not enough. So let me go back to 2. Oops. So 2 volt gives a very bright light, and I burnt this one out by giving it 3 volts. But these others are still live. So let me probe this a little bit more. So I would like to see. That feels like this is going to go this way. But quite frankly, I'm not sure this is a visible light LED. Let me flip it over and see if I can. So it's interesting. It's got some test points and traces which go right into this agglomeration of twisty leads. Oh, I guess this may be a voltage regulator here to give it the precise voltage it needs. And it looks like there's 2 empty pads for LEDs they didn't actually put on. Oh, I'm sorry. I bet that this is not. I'm sitting here saying, I'm trying to get the LED to light up. I'm trying to get the LED to light up. This is probably not an LED. This is the sensor. These LEDs feed light in, and this sensor, probably a CCD of some type, reads the resulting light and gives you an answer. So let's look at this again. Let's look at the mechanical part of this. I'm going to see if I can pull this thing out. I think I can. Yeah. Wants to keep holding on to the test sample. And I would prefer not to bust the vial. See, here's the bottom of the vial, and of course the fluid goes all the way down into it. And as you can see, it's kind of purple, and oh, look at that. There's actually, it actually comes all the way through. So when you seat this little dingus here punctures the bottom of the vial. That's very interesting. So I'm actually, I haven't touched any of that, so hold on a second. So I'm going to put the vial and its remaining contents into this disposal bag that they provide. But that's really interesting. So since it punctures the vial and drops some of the liquid in to a little chamber in here, that explains a number of things. Number one, it explains why the vial locks in. It's one of the reasons why the vial locks into the stand. Number two, it explains why there is some sealant material, probably silicone grease or whatever here, to keep any leakage from happening. That's why there's this little pad. I'm going to assume that's why there's this little pad here. And the other thing, and this is speculation, I think this tells the system that this has been sitting here undisturbed through the whole test. If it loses some cross connection, it's making sure that this pad is on these traces through the whole test, so you know it hasn't been dislodged or whatever. And there's a little flat surface here which sits on top of what I now know to be the sensor. Now inside of here is kind of interesting too. We'll pull it all out because I haven't pulled it out yet. Well, we'll take this little ring off first. Now, we'll see if we can get, see, can't tell if you can actually see, but there are little lenses here which sit on top of these LEDs, and then they go to rods which go to the center. So they're focusing all the LED lights inward towards this chamber where the sample to be tested is probably residing. Actually, it's not. Okay, I'm seeing what's actually happening. Again, I have not seen this before. These are all little chambers containing some of the fluid. So the next thing I have to do is get this, and so the light from the LED goes through this chamber and continues on to the center part, which is what's being sensed by this sensor. If I can get this out, which I can, I'm going to have to break some stuff, but I'm pretty good at breaking stuff. Oh, no, it's just going to come out. Okay, it just came out. So there's the little chambers. There's a chamber and an LED light tube, chamber, light pipe, chamber, light pipe, all coming down into here. And again, the stuff is distributed from here. There are also little, oh, you can actually take the top off the chamber and you could pull some of the fluid out if you want. I obviously don't want to do that, but you can if you want. And these plastic parts, plastic tabs, are just that. You can separate. We can separate this whole thing. I'm going to do that off camera because I don't want to do it right here on my workbench. I'll be back in a minute or two. So I took the test chamber apart and saturated it rather thoroughly with isopropyl alcohol. So yeah, that's pretty neat. There's one more layer here that can come out. Oh, this is like silicone rubber. Okay. So again, the sample comes in through this, goes through this channel, this is a channel in the plastic, out to this little pushy thing, or whatever you want to call it, pointy thing, which has another channel molded in it, which deposits the material to be tested in these little chambers. Then the chambers are mounted over the LEDs, like so. The LED light comes in, shines in, points that way, and illuminates all collimates in the center. Now there's no focusing. Well, actually that's not true. You probably can't see this. It's molded a little like a prism, so it's guiding the light down at a 90-degree angle into the center and onto this sensor. So it's going to analyze the color and determine whether it's a positive or a negative test. So let's go through it one more time. What happens is I'm going to back off a little bit again. You put your vial in here, press it down, the way it was described to me. You set it in here first, swab your nose, run it in there about 30 times, then you push firmly. Now what I believe is happening when you push firmly is two things. Number one, the vial itself is being punctured by this. That's a little piece of metal molded into this plastic. So that's punctured. I also believe, and I didn't see it in operation, so I also believe that pushing it down also makes it go, this black piece go in to the sample chambers. So once that happens, let me see if I can get this part again. I'll speed this up. And again, there's this plastic membrane that's on top of this to keep things from flowing around where you don't want it to. But yeah, the material goes through those channels down into the test chamber. The LEDs are illuminated. It senses, and based on the color or other frequency characteristics, it says yes or no. So that's pretty interesting, isn't it? And really kind of neat. A couple of things I don't know. For example, I don't know why, I'm looking at this case. No, doesn't tell me anything. I don't know why there's a large gaps here and here and here and here and here and here. I don't know whether that's for electrical isolation or something else. Just don't know. But that's it. Okay, now we know how it works. Pretty neat. Hope you enjoyed the video.